Hi everyone, my name is Dale, and along with Rachel and Raina, we'll be presenting our research on forest succession in Point Pleasant Park following Hurricane Juan. We analyzed long-term Biology 2060 forest plot data from 2004 to 2025 to understand how the forest community has changed and whether it's following the expected patterns of Acadian forest succession. Point Pleasant Park, or Amundu Gadi, is a culturally significant area for the Mi'kmaq people and part of the Acadian forest region, which is one of the most diverse but also most endangered forest types in Nova Scotia. In this region, natural disturbances such as wind throw, insect outbreaks, and hurricanes play a major role in shaping forest structure and triggering secondary succession. Secondary succession refers to the gradual recovery of vegetation and species composition after an existing canopy is removed, but soil and seed banks remain intact. Hurricane Juan in 2003 produced extreme wind throw in Point Pleasant Park, flattening large areas of mature forest, resetting much of the ecosystem to an early successional stage. In theory, an Acadian forest should gradually transition from fast-growing pioneer species towards late successional species like red spruce. However, urban forests often deviate from classical successional pathways because of added pressures such as heavy park use, compacted soils, invasive species, storm damage, and browsing by deer. These factors can slow, redirect, or even prevent a forest from returning its pre-disturbance state. Because of this, it is uncertain whether Point Pleasant Park is actually progressing along the expected trajectory for Acadian forest succession. The long-term monitoring dataset collected by Biology 2060 students provides a unique opportunity to evaluate how the forest has changed over 2 decades and whether it is recovering as predicted. Now that we've introduced why Hurricane Juan created uncertainty in Point Pleasant Park's recovery, our next step was to define what we wanted to understand from the long-term Biology 2060 dataset. Our first objective was to interpret the forest monitoring data collected annually from 2004 to 2025. This data set includes tree density, species composition, and community matrix, giving us a detailed picture of how the forest has changed over time. Our second objective was to determine how the forest community has responded since the disturbance, because urban forests don't always follow classical succession patterns. We wanted to see whether Point Pleasant Park is showing the expected shift from early successional species toward late successional species like red spruce. Our third objective was to evaluate whether long-term trends match what Acadian forest succession theory predicts. This includes looking at changes in dominant species as well as changes in diversity, richness, and evenness. Finally, we aim to connect these observed changes back to broader ecological concepts such as disturbance recovery, succession theory, and resilience, and consider what our findings mean for the future management of Point Pleasant Park as an urban forest. This helps link the science to practical implications for maintaining a healthy, resilient park.
Our data was collected in Point Pleasant Park, or Amtukati, in Halifax, Nova Scotia. After Hurricane Juan in 2003, 6 permanent 400 square meter plots were established in the most heavily damaged sections of the park. Each year since 2004, excluding years with major weather disturbances and the COVID-19 pandemic, Biology 2060 students have surveyed all trees with a diameter equal to or greater than 2.5 centimeters at breast height, or around 4.5 feet above the ground. We used DBH shapes to measure tree trunk diameter. Tree species, counts, and DBH were all recorded on standardized field sheets and later compiled in Excel for analysis. The data was analyzed using linear regression to evaluate how total tree density, dominant species abundance, and community diversity changed between 2004 and 2025. This method was chosen because it clearly shows the long-term directional changes, which are key indicators of succession in the park.
Today will be answering the following questions.
Our first research question focuses on how the forest community in Point Pleasant Park has changed over the 22 years since Hurricane Juan. Because the hurricane reset much of the park to an early successional stage, this question allows us to examine whether the forest's recovery is following the trajectory predicted for the Acadian forest. Based on successional theory, we expected to see several key patterns emerge in the long-term dataset. First, overall tree density should increase as regeneration fills the canopy gaps created by the storm. Second, we predicted a gradual return of late successional shade-tolerant species, such as red spruce, which are characteristic of more modern Acadian forests. Finally, we expected that community-level diversity and structural complexity would increase over time, reflecting the transition from a disturbed early successional forest towards a more stable mid-successional community. This research question sets the foundation for our results, helping us determine whether the forest is recovering as expected or whether urban pressures are altering its long-term trajectory.
In response to the second research question, we expect to see a change in the dominant species between 2004 and 2024. However, we think that the original dominant species will remain, but a new dominant species will have appeared and then increase much faster over time. This is a linear regression on the density of red spruce in Point Pleasant between 2004 and 2025. It has a p-value of 0.0004, which means that it is statistically significant, and year is a good indicator for density. However, because the r-squared value is 0.13, that means that only 13% of the variation that we see in the density is actually accounted for by the year. However, it is important to note that it is still a positive trend upwards, which means that the density of red spruce is increasing over the years. Very similarly to the last slide, this is a regression analysis on red maple in Point Pleasant Park, and this one has a p-value of 0.0003, which means that it is once again statistically significant, and it has a very similar r-squared value of approximately 0.13, which again means that only 13% of variation in density is accounted for by time. As we saw in the last two slides in figure 2 and 3, both species have increased in density since 2004, but red maple has increased much faster at a rate of around 2.2 trees per 400 meters squared per year, as we can see in the equation on the graph, as opposed to 0.3 trees for spruce, according to our linear regression. On the right-hand side of the slide here, we have figure 4, which are the equations from our linear regressions earlier, and this just helps us to visualize that red maple is increasing much faster, even though at the very beginning in 2004 there were more spruce trees than there were red maple in terms of density. This makes sense with what we know about these trees, because after an environmental disruption on a forest that causes secondary succession, which is what we're seeing, there's a loss of canopy, which means there's a lot of sun on the forest ground, giving sunlight to smaller plants that don't usually get a lot of sunlight due to the canopy. The red maple is only slightly shade tolerant as opposed to the spruce that is very shade tolerant. So with this excess sunlight, it's able to very quickly grow. On the other hand, the red spruce grows more slowly than the red maple. So the red maple is a more dominant species right now, but we are in the early stages of succession. And the red spruce is a late successional species because even in the shade, when the maples sort of start to see limited growth, they will be able to continue to grow and increase in density. Analyzing these changes are really important because Point Pleasant Park is a public park and it's under the care of the Halifax government, and they need to know how to appropriately care for the forest and know when to intervene. So by doing this research and determining if the changes we're seeing in our forests are natural or a result of human interference, it's very important in terms of how we choose to continue to care for the park.
Figure 5 shows the Shannon Diversity Index, a measure of both species richness and evenness, and how it has changed in Point Pleasant Park between 2004 and 2025. We can see a steady increase in diversity over time, meaning the forest community has become more complex since Hurricane Juan. We want to look at how the Shannon Diversity Index has changed over time and use this information to predict what will happen to this measure as the forest reaches its climax community. Right after the hurricane, diversity was low because the community was destroyed and only a few pioneer species could quickly establish themselves. Over time, and as conditions improved, tree abundance increased, which leads to the redevelopment of the canopy. Now, 22 years after the hurricane, we can see how diversity has continued to steadily increase as the forest goes through these successional changes. We predict that as the forest moves closer to its climax community, diversity will slightly decrease and level off because the canopy will close and fewer light-dependent species will be able to grow. At that stage, competition will stabilize the community, resulting in a mostly constant diversity index.
Through our analysis of the biodiversity seen in Point Pleasant Park, as well as the changes in our dominant species, we have concluded that Point Pleasant Park is still in early succession because we are not seeing a leveling off of both the dominant species as well as the biodiversity. When we approach the climax community, we would see less biodiversity increasing, as well as no directional change within a dominant species and its density. However, it is important to note that predicting succession in urban areas can be very difficult as there are a lot of different interruptions in the ecosystem. There's a lot of people as well as pets that filter through the park on a daily basis, which can disrupt the environment, which can change how succession looks as opposed to a non-urban area. This can result in things like increased forest fires, which can result in a lot of destruction. However, interestingly enough, it can also do the opposite sometimes. The red maple, which is our current dominant species, has shown increased growth in certain studies across rural and urban areas in the eastern United States. When caring for the park, I think it's important to consider the 7 sacred teachings, which are indigenous guiding principles. They are love, respect, courage, honesty, wisdom, humility, and truth. And I think that love and respect for the park ecosystem is something that is very important to keep in mind and teach all visitors of the park. Thank you. We would like to start off by acknowledging that the land we did our research on belonged to the Mi'kmaq people. We would also like to thank Dalhousie University for giving us the resources to do this research, as well as Professor Zaguris, who coordinates and supervises our lab and research, as well as conducted our data analysis. Lastly, we would like to thank all past Biology 2060 students who collected the data that we used in our research. Here are our references.